Well, this is something slightly different. So, one thing you may notice today is gloves. The reason I'm doing that is that this is a old, interesting pH meter, but it's a used pH meter out of the trash, and obviously it's got a fair amount of something on it. I would imagine they're probably metal salts of some variety, something like that. So what I'm doing is I just, as a precaution, I'm wearing gloves, and I'm actually on a different workbench that I can wipe down with like some cleaner afterwards. But this is an old, large, completely analog pH sensor. As you can see, it's got a, some big, chunky, fun knobs, temperature, electrode sensitivity, ISO, pH, and buffer adjustment. So I'm pretty sure at least the buffer adjustment is used. You put it in a neutral buffer, and you tune it until it's nulled. I confess I'm not entirely certain how these work, though I do know that one of the things that makes pH sensors very interesting is they have really, really, really high input impedances, like femto or picoamperes, because basically the electrode system they use to measure the actual pH basically can't source any current at all whatsoever, even a little bit. So we should just see some interesting input stuff. So you can see here, obviously this is trash out of the University of California, Santa Barbara. On the back we have electrode. I'm actually not too sure. This may be like a glass calomel chassis Paul line and fuse, and then we have an external TC, which I would assume is for thermocouple. And then there are these two recorders, 10 millivolts per pH and 0.1 milliampere per pH. And they're all obviously kind of horribly corroded and kind of nasty looking. Interestingly enough, this rear panel here looks to actually be done on a piece of FR4, and you can actually see that this is copper, except where it's corroded here, where it's turning green. Well, I guess it's still copper. Made in Denmark. It uses 0.1 ampere, 115 volts, 0.1 amp slow blow. And then it has this little arm over here, which I would assume holds something that just holds the thing in the solution. And then here's the cord, which just runs into a grommet. So, I'm not too worried about tertiary transfer, so I'm going to just go ahead and use my tools straight on it and just, assume that the amount of stuff that will transfer from my hands to the tools, and then back to my hands, and then somewhere it's probably not that large. I'll probably wash my hands even. So let's take this little arm off. So most of this is going to just go straight in the trash because I don't want to have to deal with trying to dispose of it properly. Or, well, I guess it was just in the techno trash, so it's just e-waste, but I don't want to have to deal with trying to like rehabilitate it for whatever that would involve. Like cleaning it properly, because I don't know necessarily what cleaning it would entail. Chemistry is a little outside of my area of expertise. So it looks like the top cover just lifts off. Okie dokie. So we are in. And this is quite the interesting construction. Actually, it appears that it's basically the only relevant section of the circuit is this back plate, which actually includes the connections for the rear. That's basically the only circuit board in here, and then if you look down inside there, it looks like it's just front panel controls, lots of beautifully laced wiring, and the big panel meter, which I may recover because that's a really beautiful piece of kit. So, oh cool, the board is, you really can't make it out in there, but the board actually has labels on it. Let's see. That's pushing on this side panel. I don't understand. So this has this edge connector here, but you have to remove this side panel to disconnect it because it's got these standoffs which are screwed into it. Also, look at this nice little touch here. They're showing this as a ground with this nice little ground label. Isn't that beautiful? This is like really exquisite. Also, look at how they look at the trace joints. We'll get, you know, I mean, they just have this little triangle area for the trace joints. It's still hard to even do that with modern CAD software. Oh, whoops. I want one of the adjustment knobs. So here is this, which has a whole bunch of what looks like high precision resistors on it. I'll put that aside. I can just set up there for the moment. Yep, 0.05%. That's what I just saw on there. I really don't understand how where the power supply is, because I don't see a transformer anywhere. What am I talking about? I am the stupidest person alive. So anyways, power input, fuse, it looks like they just use because this is low power, they actually just put a big series resistor in series with the input to change the voltage. That's actually a fairly common practice in older stuff, so you can actually see here, this is for 120, 150, and 220 volts. You can actually see it's labeled, it's a resistor specifically for that, and that just drops energy as heat, but I guess they have a big cabinet that everyone can. It's obviously not the most energy efficient way of doing it, but what have you. So here is our board. So first of all, transistors and vacuum tubes, which is quite intriguing, with what looks like, I would put money on it, this is mu metal shielding. It's going to move out. Ooh, nice. Are they in? Yeah, they're in ceramic sockets. These are quite nice. So I wonder what this tube is. One thing you notice is the pins are gold plated. How is this? Is this just pressed into the shield? Does it say on here? No, they're just called V2 and V1. Interesting parts. I guess it was just a spring force thing. So this is an Ampex 6084. It looks like this is I think it's just a. It looks like it's a pentode, I think. I'm not totally certain, but it looks like it has 3 grids, so I think that's a pentode. Up. We'll unwrap this one. So this is probably actually like electromagnetic shielding. This is another 60. I think it's another 6084. It's harder to make out on this one because the labeling is rubbing off a little bit, or just come off. But anyways, yeah. So this is a you know, these are just basically single tube or single device tubes. You don't have, like, it's not a dual or a quad or anything. So this is an interesting bit of kit. So what we have here, ooh, interesting. This is a Radiometer Copenhagen photo chopper, 40 volts at 50 to 60 hertz. So this looks like it's like a chopper controlled amplifier of some sort. As you can see, obviously it looks like it's getting something big coming in here, and then it comes in this whole can. Actually, if you look here, you'll see the probe pokes in through this bulkhead fitting on there and comes in, and then there's an electrode in there, which is where I would assume the other terminal is. So I bet most of the interesting stuff is in this housing. You can also see that we have these 2 little tines which grounded the casing on the shield. other stuff on the board that's interesting. We have a jumper here, so I guess they have two ways of converting. And then over here we have a negative 15 volt regulator, plus 15 volt regulator, some caps, 470 mics at 50 to 60 volts DC. And then here we have 22 mics at 250, 275 volts DC. You can see here we have some interesting old transistors. That is a three-legged device, but it's in a can. That makes me think that's almost like a... I wonder if that's a whisker transistor, whatever they're called, I forget, God. One of the really early transistors, the one that used, you know, metal whiskers rather than epitaxy to produce them. And then, whatever this is, let's actually... you can see we have this kind of rather elaborate spring retaining this, I would assume it's socketed, yeah it is. And then actually that's quite interesting. There are these little green tabs poking through, I don't know what they are. So this is quite intriguing. So we have two leads that come in here, and then three leads on this side through what looks like, I think that's probably Teflon. Yeah, or an early variety of Teflon. And then there's actually a capacitor hand soldered from the case to one of the pins, and it looks like this is a, that looks like a mica. And then if we look down in here, we'll just see there are some copper tines. And then here's this interesting, look at that, it's polarized. Other things of interest are you can see that this is in fact not an edge connector, it's a, that's interesting, look, these are actually, it looks like I think the other end here, yeah, so they're two sets of tines that go together like this, which I would suppose actually give it 4 contact points, which is pretty cool. It's interesting, kind of double coiled spring, so it's springy, you know, when you pull on it that way. So this is obviously just electromagnetic shielding that sits over there. So here we see here at the bottom of the two vacuum tubes, and that's actually quite interesting. Look at this. We have, I would bet that's part of, oh hey, spacers. I would bet that's part of the high impedance stuff because it's running up through a hole or over the board. This isn't on the surface, it's slightly above it, and then down through a hole into one of the pins for the tube. So my guess would be that that's the high impedance input. I'm not actually too sure what the rest of it does. Let me take the rest of the screws for that metal cover off. So here's the inside of this casing, and you can see we have like insulation standoffs, and it's flying to this, and then it looks like the input from the transducer, which is this right here, goes to this pin, and then coming from the other pin is a couple resistors. Actually, this lead going down here through this device here goes to the vacuum tube. So my guess would be that this is the input, this is the output to the rest of the circuitry, and then possibly the central one. Yeah, that just ties down to a trace. So that it just runs down to a little lead that runs right down to the PC board. You can see it just runs straight down. So my guess would be that that's like the reference level for the chopper. So what I would bet happens is this electro-optical chopper oscillates between connecting these two and these two of some sort. And well, I'll take this apart in a little while, though I'm not sure how. It looks like it's one unit. It looks like it's kind of crimped on at the end. I'll have at it with wire cutters, I guess. It's just aluminum, I think. But I mean, I would imagine that it's a very, very, very high, open resistance switch of some sort. Anyways, you can see in here we have really fancy pants resistors, and then it looks like there are some, crap, I forget what those capacitors are made of, but they're the wound up with film there. And then there's some caps and resistors down in there. Alright, so there we are. So you can see lots of interesting stuff going on in here. So we have input lead. Here's the lead that I'm pretty sure is Cal. Actually, look at that. One of these capacitors appears to have a broken lead. That could have also been what was wrong with it. I would imagine that goes to this terminal here. You can see these wound capacitors. It's two layers of film wound up with like polypropylene or mylar or something like that. And then here's our output, and it looks like our output has a cap to the terminal going into the vacuum tubes and a couple caps going down there of some sort. You can see there's C6. There's some more stuff going on down here. There's a cap. That cap down there is straight from the electrode. And then we have these big, I would imagine these are extremely high impedance resistors. And these are actually, these green epoxy lumps appear to actually be capacitors. That's kind of unusual. And then you can see there's some other big plastic box film caps. And then here are your voltage regulators with what looks like exposed tuning potentiometers. These are, you can see these, all of these appear to be, that's 13.42K, 0.1%, 0.1%, 0.1%, 0.1%. These seem to be very, very high precision resistors. Or not very, very, but high precision. And I think I saw some higher precision stuff elsewhere. Look at that, it's an early bridge rectifier from the look of it. SCMIKRON, semicron. So there's actually two bridge rectifiers. There's this one here and there's this one here. And then down here you can see these two red components are very old school diodes. They're actually, you can see the old school package where the necking down indicates what the diode would, where the bar would indicate nowadays, excuse me. Incidentally, I found the resistance on at least this part. It's 50 mega ohms, which is about what I would expect. You can see we have, actually that's an interesting thing. Just looking at the whole board. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There are a total of 10 active devices on this entire circuit. Which kind of shows you what you can do with, you know, some clever design and, well, I guess 11, arguably. So this whole thing only has 10, you know, active semiconductors of some sort, which is pretty goddamn impressive when you consider what it is. You know, ultra high input impedance. It's got a lot of high precision resistors and a lot of various kind of fancy pants parts. I mean, you see all these, you know, I wonder what delineates these like epoxy blob capacitors from just like the straight up aluminium electrolytics like these here. These might actually be film, but their value seems a bit high. Oh wait, no, these are 0.1 mics, so I don't know. That's interesting. Some old aluminum electrolytics, and then these big film caps. So some of the stuff I was talking about on the layout, here's the other side of the board, and you can just see it's just exquisite. Just look at some of the trace patterns here. Actually, that's interesting. I wonder what they're doing there. But like you look where the traces join, you have a little triangular land of copper. I wish we could figure out some way to replicate that with modern CAD tools. Nobody's done it yet in any event. I mean, it's not really needed, but I just think it makes the product look so much nicer. You know, little arty touches like this ground over here. Or, you know, I mean, because this was all done with, you know, paper tape, so there's no restriction to, you know, orthogonality of any sort. You can see we have holes here, here, and here for adjusting the 3 potentiometers. On the other side, which you can see here are positive, negative, and this one's marked 0, so I guess for calibration. So this is detector output amplifier is what the connector's labeled. one thing you'll notice is that we have input circuit here, amplifier, plus 15 volt regulator, 1915 volt regulator, power supply, and then this is detector slash, oh I see, this whole area here is the detector and or output amplifier. Intriguing. Oh I see, yeah, because this is obviously running the chopper. So this is probably, this electronics here together with whatever the hell this is, form the chopper. Cool. I'm definitely kind of curious about some of these transistors, like these ones that are laid down. They're very interesting looking. They might be germanium or something. They're all... What is that? I don't even... This doesn't have a traditional 2N part number or anything like that on it, which doesn't surprise me. Anyways. So the only other aspect of this of interest before I start hacking at the chopper is, here is the front panel. You can see here, this is the power switch, of which I unfortunately broke a little bit. But if I go to the front panel knob and you can see there's off and on. Actually, I'm not too sure, because that's the heat setting, whatever that means. I would actually have thought that this was the power switch. There's a big kind of clicky switch in there that's got sticking issues. Other stuff of interest, look at these pots. Well, at least look at this pot. That is 5.000 ohms. Wow. And then it's got a high precision resistor across it. And look at this. It's you've got like a it's waxed twine lacing. It's sticky. I've got lubricant, and you can see here are some 0.2%, 0.05%. Really high precision resistors and so forth. There's two very nice pots, and then just some scummy, you know, generic pots. And then this is a really shitty, that looks like a carbon comp pot, whereas this is at least a little more sealed. Are these multi-turn? Nope, it's a single turn pot. I wonder why they're so gargantuan. And then there's, it's hard to see, but down in here is just oodles of precision resistors. I might actually take this apart just for the precision resistors and build myself a reference or something. Because I bet they're still pretty damn accurate. That would be useful for calibrating stuff. Boy, if I can't separate this. So here is one just gargantuan panel meter. See this huge panel meter, you can see the little outline. It looks like the display panel's free. I am totally going to save that. Actually, it looks like this. May just... how is that supposed to come out? So here is the panel meter. Look at that thing jiggle. So that has just two connections, and then this is... I'm actually not too sure what this board is doing. It's got three interconnects. Also, kind of frighteningly, kind of gross, slightly worrisome. Alright. And then now that this is apart, you can look in here and you can say, look at all those high tolerance or high precision resistors. Just most of those are 0.05%. 2K 0.05%, 2K 0.05%, 18K 0.05%. Wow. So that seems to be related to the expanded scale mechanisms. So now this just pulls right out. I may keep the circuit boards from this, but I don't think I'm not gonna hold on to the housing. But yeah, here are all these high precision resistors. You can see here are the knobs, and there are those enormous. Oh, I'm sorry, it's not 5 ohms, it's 5,00. Or I think this may actually be 5 ohms. I can't tell if that's a dot or a period. That 5.0 or 5,0, because if you look at this one, that's definitely 10,000. They sure feel nice. They've got like the silicone oil and the bearing lubrication thing going on. I will put this in my slightly frightening boards junk pile, along with this one. Alright, so now the kind of the pièce de resistance, which is whatever the hell this is. So it looks like this was inserted and then this end was rolled over. So okay, that's free. Intriguing. So, wow, of all the places to find just utterly boring TO92 package devices. So here is our little electrode block. Oh wow. So what we have in here are two what look to be photoresistors of some sort, like cadmium sulfide, that then sit into these holes and are apparently illuminated by something in here. And then this is just all control circuitry for that. Very interesting. But yeah, you can look, so you, let's see if you'll focus. So there are two little, I mean, it's not like a wavy line, they're just straight line. These covers come off? No, they don't appear to. Oh wow. Is that what I think it is? Yeah, these are in hermetic glass envelopes. You can see they go down there and then it goes through a wire bond. Or, excuse me, a wall into the... I can't tell if they're hermetic or what. It's certainly interesting. Their number is CL1050, and then they have 15%. CL1050, and then there's 15% there. I wonder what this does. I mean, because these look like photoresistors, which mean it can't be like a straight up switch of some sort. Though it does appear that I was correct in that it looks like this pin is common, and then this one goes to the center pin, and this one goes to this pin over here, because you can see the lead from there goes around to here, and from there, and then from that to that, and that to that. But I think it's quite interesting that how this works. I mean, these just sit like so. And then whatever the heck these are. But I mean, yeah, just generic, or well, generic looking. I don't see a part number on the transistor. What? Oh, yeah, I do. Motorola MPS L01 EBC. Just an MPS L01, it's a Motorola part. I wonder if this has been replaced later in life. What does interest me is what is with these, the illuminators. I mean, are these bulbs? What's holding that on? That seems to just come out like that. I think so. If you look in here, you'll see there are little helical springs. So I think these may be neons. As ridiculous as that sounds, it looks like I see a glass pip on the end of there. Does this win the most ridiculous use of neon lamps award? Alright. So yeah, it appears we just have two wires entering each one of these, and then they're just sitting on posts mounted to the PC board, not even through it, just to it. Oh, no wait, they've been heat staked down. Like the leads then run to these terminals here. I guess neon is nice for this because they can be totally sure it's off, you know, if it hasn't struck. But it appears this comes out just kind of gently. No, not anymore. It moved a little bit. Oh, now let's put it back in. Oops, I'm making a mess. Seems like Bakelite. So that is just an end cover. And in here we have a neon bulb. I was right. So these are just like, I mean, well, the elements in that are quite long. This is a very large neon. But it appears that these just use two little neons. Signalite RT2-32-1A branded. And then they fit in this little clear plastic of some sort. I mean, I guess this was probably very early plastic, so whatever the clear plastic is kind of probably fairly exotic. Because I know that at least during the Bakelite days, they didn't really have clear plastic. Oh, that's intriguing. So here's the cowling, and it looks like the way this is designed, you can see it's got this mirrored finish on it, or it's actually got a little rolled up metal shield, and then it's actually it's corrugated. And I would bet that that's designed to try and capture as much of the light coming out of the sides of the bulb and basically act like a light pipe and focus it down the end. That's quite interesting. But I mean, I guess the fact that they're using neon makes perfect sense because this probably chops very fast. Well, you know, faster than a hertz or two. And, you know, if you tried to turn a light bulb on and off, you know, at several hertz, it would die out in days. So I would imagine they have to use neons, just because anything else is just, you know, basically anything but a neon would, you know, that they had at that time. Basically all they had then was neon and gas discharge. So anything other than a neon would probably die in very short order. This little control circuit board has some numbers on it: 570-029, 67-PT-02-1, and then 570-030. It also says long and Kort, K-O-R-T, on it. Just a little bare copper board. It's got the same numbers on the back side. Oh, that one just came right apart. I guess I just did the other one wrong. Interesting bit of kit. I mean, I think I'm most surprised by this. I wonder... I mean, I guess I'm just most surprised by these sensors. I mean, I wonder... I mean, they must go pretty freaking open circuit to be open circuit at, you know, the impedances this stuff deals with. I mean, these must go to like giga-ohms or something along those lines. You know, I mean, I would imagine that when they're conducting, they're not really very conducting, you know, maybe a few 10 or 100K, because I think it's acceptable. But, I mean, I guess, and a lot of this is probably, I mean, this whole aluminum thing is probably just to keep light out. Like, I don't know if you can tell, but this is very, very heavy, thick plastic, and then we have this brass, which has O-rings all around it, presumably more for more light gasketing. And then, you know, that fits into here. And then we have more O-rings, which I would imagine are, you know, even more light gasketing. In retrospect, I think the springs in here are probably shielding. Because, you know, again, you want to make sure nothing can couple into there. So I think they just have a helical wire that looks like a spring, but it's probably just a shielding mechanism. And then they have these O-rings sit into those tubes just for more protection. But yeah, anyways, I hope you found this interesting. I certainly did. It's a lot of effort they put into these things. Just the intricacy involved in making something like this for, you know, and the cleverness involved in how they gated, you know, using CDS photoresistors and look of it, or they may not be CDS, but some sort of composition photoresistors to do chopping at the point when, you know, and then neon lamps when they couldn't, you know, I mean, I guess they couldn't use a relay, though I do know that you can buy reed relays which have cycle lives in the terms of like 10 to the 8 or 10 to the 9 cycles. I guess this probably does better because it's completely solid state. Well, does gas discharge count as solid state? But yeah, it's a cool bit of kit, and I hope you found this interesting, and kind of a bit of an insight into how they did exotic high impedance stuff before they really had, you know, FETs.